We're going live. We tune it in. Let's see if this stream preview comes up. Oh, we're on. Fish on. Okay, team. We've got to finish up the code for this notebook. It's been running in the background here. So I'm up to here. I've got to fix the uncertainty prediction intervals on future forecasts. And then we also have to introduce the turkey problem, plus just see how poorly our model predicts on future data. So let's do that. We've got data up to May 15 for Bitcoin. So we're going to see how our model can improve from there. I need to sneeze a lot. Oh! I wonder, there's a chat pop-out thing that I can do. Oh. Beautiful. This might be much easier than what I was doing before. Okay, let's make us some room on the screen. We'll wait for people to join in. We got some good plots before, predicting the future price. But now we're kind of stuck here when we predict the... Yeah, why is there a variance of 1.8 million? That to me seems very high. What happens if we get the variance across here? That's still very high. That doesn't make sense to me. Let's have a look at this. Ensemble forecast values. What if we got the standard deviation? Ashik, what's good, my brother? How are you? TensorFlow standard deviation. Reduce STD. I don't believe there should be that high of reduce STD, ensemble forecast. Let's see what this comes out to. Don't tell me. Oh, TF math. Yes, that would be amazing if you could post that. I'm streaming on Discord. Thank you very much. I'm just going to get straight into the code today because I want to finish off the code today, and then tomorrow we will... Okay, so maybe the standard deviation is better to plot than the variance. Because these variance numbers are just absolutely spectacular. Like, I wonder if we use NP... Does NP variance have? Red Hunter, you can use almost anything you want as a feature. If you can encode it numerically, you can use it as a feature. Whether that feature adds any help to your model, well, that's another question. NP-var. I wonder if we get the same results here if we use NP-var, because I swear to God, I'm not sure why. Ensemble forecast values, yes, and the axis equals 0. Are we going to get the same variance here? Okay, we do. All right, let's just plot the standard deviation. We'll subtract the standard deviation. see, what if we look up standard deviation? Math is fun. How spread out numbers are. Okay. So if we're using a normal distribution, thank you, Ashik. Done, master. You don't have to call me master. We take the middle value of each forecast and see what happens. What if we get the mean? NP mean. Does this change our forecast much? I'll keep this as median. So right now we've got an ensemble model that we're using to predict the price of Bitcoin. As we'll see, it's going to perform quite poorly. Forecast, let's create the mean as well. NP mean. Ensemble forecast values. Axis equals 0. I want to see how different these two are. And let's minus each other, minus them from each other. Hey, these are the same values. Ensemble forecast mean minus ensemble forecast median, and let's get the NP absolute values of this. TF absolute. Okay, so they're not far off each other, except for this one. Same with the standard deviation. Let's minus the STD and the STD. Okay, so we get quite a large. So this is our uncertainty estimate. This is pretty good. It's an advanced, imagine, it's not linear regression per se, but that's what we're trying to do. We're just a line of best fit, right? But the model we're using is, just imagine, because we're using a fully connected neural network, it is just like logistic regression on steroids. So if we look up logistic regression formula, someone please just show me a simple formula of this. Okay, so there's logistic regression formula, but if we get dense network formula, you'll notice that they're quite similar. Yeah, we've got weights and bias vector here. We've got a weights matrix and a bias vector. Whereas logistic regression, you have weights and some sort of exponential activation function. We're not using an exponential activation function. But yes, basically, that's for univariate time series. For multivariate time series, well, I guess you just only have another. You could say that then that's only just another weight matrix. Yes, it is glorified linear regression, line of best fit. Okay, let's extend this plot to. This is the future data. So the data that we have only goes up to the 18th of May. And maybe I will do the same with this plot up here. What if we change this? No, we'll stay where we are. See? Our model starts to gain some kind of seasonality to it. So what I mean by that is we can clearly see that these peaks are starting to form a pattern. Whereas this is one of the downfalls of time series, right? Is where we just have to. You could quite easily remind yourself of how poor your model is going to perform when you just remind yourself of what you're trying to do. You're trying to predict the future, right? So it's like you're looking into a crystal ball here. Let's keep going with our uncertainty estimates. To me, it makes more sense to plot the standard deviation, because if we do the variance, I mean, the variance gets ridiculously high. So if we go variance, look at this. Yeah. We have a variance of nearly 2 million, plus or minus 2 million. That's the turkey problem though, right? Or one form of the turkey problem. We'll get to that soon. I'm going to leave this as standard deviation. But now let's plot the previous dates of Bitcoin. So we can go plt.plot x all, y all, label. Wonder if this will work out. Historical data. Excuse me. Label equals historical data. Okay, x all is not. Oh, I see. So this is actually. Yeah, that's what we've got here as well. We notice that we use difficulty as a feature in multivariate time series. That was our second variate. It didn't really add much. There. So the trend here is, you can easily see this yourself, right? The block reward goes down, the price goes up. But again, we're working in an open system. So these are not the only variables that contribute to the price of Bitcoin. We could include things like trade volume, but Again, I feel like we're going to be getting much the same results. We just can't predict. And plus, the only moves that really matter in the long term are like the large moves. So we're going to investigate that shortly when we realize that our model can't actually capture those. So like black swan events, for example. So now let's offset this a fair bit so that we have some sort of we want offset. This is quite tedious. I want to make a function for this. I think we could use our plot function. Anyone who claims they can predict like stock prices and any sort of open system, this is what you got to realize. Open system. You know this intuitively from the weatherman or weather predictions. Open system. How often do they get that right? We've seen in the previous streams that one of the best models for our entire Bitcoin open system or stock price prediction, Bitcoin price prediction, is the price of the previous day. We had to work very hard to build a model that would beat a model that just predicted the price of the previous day. Nonetheless, we are here. If you have a closed system, I'm very confident that you could use forecasting to predict, to help you out. But I just want to show you how poor time series modeling is for open systems. Time steps equals Bitcoin prices, values equals, what do we just have? While. And then start equals offset. Label equals historical data. Ensemble forecast. I think we can... Okay. This is good for me. I actually want this offset to be quite bigger. Zoom right in. Oh, too big. Too big again. Why is this not working? $27.80, so let's get the last 80 days. Haha, there we go. Okay, so now we just have to line this up. We need a legend. Yo, Hasmanator, what's good? Viable clan member, you can add as many features as you want, but basically with any kind of open system, you almost have to reinvent the entire world to capture relationships. So, and plus, the predictions that you want, your model will never be able to capture, as in the things that you cannot predict. This is what a lot of people don't get with time series predictions. Sashka, yes, this will be predicted. This will be part of the TensorFlow course. I'm making the materials now for the last module. One of the biggest financial companies in the world is called 2 Sigma, right? There's a reason why they're called 2 Sigma. Investments. It's because the models that you build start failing after 2 Sigma. So for an event that's like 8 Sigma, which is 8 standard deviations, your model is not going to be able to predict that. A financial model really only predicts things within 2 Sigma. If you want the code for this, it is on the GitHub. It is time series forecasting in TensorFlow. So let's fix this now. I'll make this legend a bit bigger. We're going to connect these two because that would be much better that they would be connected. Next time steps. Get rid of that. By the way, let me know if anything that I'm saying doesn't make sense. But we can see this empirically. I'm using the median here as well. It would probably change a little bit if we use the mean, but median's a bit more robust than the mean as a metric. Let's go NP insert for the first one. We want array. So the first array, forecast median, object 0, and the value can be y all the last one. Ensemble forecast median should have the last value. Wonderful. And now we should be able to get rid of this. And we should be able to get rid of this. And we should be able to plot this. What have we got? We need to do this from 1 onwards. So we have a different shape. Hold up. Wait a minute. This is joking to me, mate. You're joking. We also need this to be 1 onwards. Okay. So we get a very high standard deviation here. Well, our model fluctuates a fair bit. Let's bring this back a little. Right, we're probably going to bring this, we'll get in some future data as well. Reduce standard deviation. Let's get the values. Let's go TF reduce min values across axis equals that. And then let's go TF reduce max, ensemble, forecast, values. This is very fun. Okay, and now, what is the difference between the min and the max of all of these? Minus, and we'll get the absolute values of all of these. Plus or minus. Okay, so we do get a good amount of plus or minus. So we could plot that, plus or minus. So that's 3 different models. We get the plus or minus predictions. Viable clan member, would day of week and day of year as a feature improve anything? I don't want to say, I don't know. I haven't tested that, but my intuition is telling me probably not, because Bitcoin data doesn't have seasonality. So we could implement that as a feature, but my intuition is saying probably not. And what if 1,000 Bitcoin fans voted buy, sell every day? Would that data help? Again, probably not. It may improve the model a little bit, right? But not in the right direction, because as we're going to see in a second, there is no way our model can capture a value. So right now, our model is only predicting values that are within its training data. But what are the most influential values on any sort of historical event? It's the large events. So what if we had an event where the price of Bitcoin reduced by 50x in a day? So what if we get the standard deviation? Bitcoin prices. Okay, so TF, math, reduce, STD, Bitcoin price. Dot NumPy. And we're going to see this when we import this would be a great example, because the data that we have in the last month, Bitcoin has fluctuated a fair bit. So our model is going to exemplify that we just can't predict. Have we done enough here? Why don't we predict further in the future? No, 2 weeks is enough. So let's see what the turkey problem is. So this is something that is very important. So let's just say this is the price of Bitcoin over 1,000 days, right? Then some event happens and it goes basically to zero. How is our model going to be able to predict this based on this? How? See, a turkey lives a really good life up until Thanksgiving. That Thanksgiving Day is not in the entire history of the turkey's life. So if we had one really large significant event that dropped the price of Bitcoin, say from whatever it was, let's say arbitrary number, 100, down to zero in one day, let's see how our model goes at trying to predict that. This is just one data point. All right, let's put that into our time series. Let's introduce a turkey problem to our BTC data. Viable clan member. Day of week, day of year as a feature, improve anything. Day of month. Well, you're saying day of month because of payday. The law of large numbers would say that the paydays would get cancelled out. Because everyone, like, I get paid like 6-7 times a month. You're not making sense. How? Use a Boolean value for whether a family is vegan or not. Price. So what if we just added on the end of this price, right? What's the last price value? I think it's like 43,000 or something in our data. -1. All right, so what if we just reduce this by 100x? BTC price, turkey, equals BTC price dot append, and we will get BTC price -1 times 100. BTC price falls 100x in one day. All right, would this happen? Maybe, maybe not. You don't know. Can you predict the future? Again, this is where time series forecasting falls down. Now look at this. Oh, what have we done here? Is not subscriptable. BTC price. Is this, is this a none type? Oh, because append is its own method, isn't it? Equals BTC price. And then we need BTC price. Append happens in the same. Append BTC price -1 times 100. So now if we look at the prices of our turkey problem, you'd want your model to pick this up, right? Divided by 100, that's what we want, of course. No! Such a simple list indexing thing and I've messed it up. This is great. Okay, we've altered BTC price. BTC price equals BTC price. Remove. Up to we may have to reinstantiate BTC price here. Okay, now we're good. Let's can this. Can this. Yeah. All right. So now, price of Bitcoin, let's just say it reduced. Turkey is an issue with any market value. Watch this video. Turkey is an issue with any system as well. It's like your life could be going great and then you walk out and get hit by a bus. You can't predict that. Boom. See, there's a Turkey problem with the XIV trade. We'll see this empirically, don't you worry. Now we need, let's go plot time series. Time steps, we're going to need to add an extra day. Manufacture an extra day, an extra price on the end to showcase the Turkey problem. We have one value, right, that is gone spectacularly low. So now we need to add an extra day to our time steps. So what are our time steps currently called? This is the problem I'll need to fix once. Bitcoin prices index, window size. Okay, Bitcoin prices index. We need to add one day. So we go BTC time steps Turkey equals right, so we need one day on the end here. So how can we do that? We actually have a method up there, but I believe we could go, we use a time delta. So BTC time steps. Let's try to do it from memory first, because why look up the documentation when you can just hack around for a little bit? -1, that'll give us our last day. And then we want to add, what if we do +1? It won't work, will it? Wait, is that a NumPy? NumPy date time. Yeah, this is what we need to do. And then +1. What does this give us? That adds 1 on the end. Plus NP time delta. This is how we can do it. Time delta 1D. Wonderful. Okay. So now we can go. I want to array this. NP array. Wonderful. And then on the end, I'm going to go np append. I'm going to add an extra day here. We're just going to take what we've done here. I believe append needs a value. BTC time steps Turkey. And then let's have a look at our time steps. Yo, Matt Jass, what's good? Matt Jax, that is. I've been excellent, my friend. I'm finishing the code today. I'm introducing the Turkey problem to everyone. Values equals BTC prices price Turkey, and label equals BTC price plus Turkey problem. Haha, that's what we want, my friends. Fig size equals 10.7. A good size. So see, look what's happened at the end. Let's bring this start equals 2,500. Boom, plummeted. All right, is this official? Well, no, but it could happen. So now let's see how much one value changes our model. So let's have a look at model 1 results. We got pretty good results with model 1. We'll just use that, hey? Model 1 results. This is model 1 results. So if we go, let's build Turkey model equals TF Kera's models, clone model, model 1. Right, same model as model 1. Now what we're going to do is, we need to create train and test sets. Okay. We'll do this here. For So we'll go back up to model 1 to see how we created our data. Okay, quite straightforward. What you know about rolling down in the deep? The drain goes no longer. Guys, I've got a song stuck in my head. For Windows, for labels, we want BTC prices Turkey. Hold on, son. Oh, BTC price Turkey. What's wrong with our prices? Let's NP array this and see if it fixes all of our issues. Boom, it does. Thank you. Okay, now let's create we're going to window our data set just like we did before. make train test splits with full windows and full labels. All we've done is we've changed one value. Maybe we should have done it on the last one. Okay, beautiful. Clone model 1, turkey model, turkey model.compile. How long did we fit model 1 for? Batch size 128. Okay. 100 epochs. Maybe I could, yeah, we'll do that in a second. I'll just change the very last value. Oh. Did I not? I think I did that correctly. List.copy. That's what I needed to do. Otherwise, it's going to influence the original. Can I change the last value of a list? Yeah, I think that's what I want to do. When your brain goes numb and you call it mental freeze. That's a fun track. Okay, let me see if I can change the last value. -1 equals BTC price turkey -1 divide by 100. Let's just change the last value in the last day. This is a hypothetical, of course. Wonderful. We don't actually need this anymore. Plummeted. All right, let's say it just plummeted on the last day. So all we've done is we changed one value. This will work much better. This will be a better comparison. Because before we added an extra value, which was 100x the previous value, 100 times less than the previous value. validation data equals x test, y test, and then we will go verbose equals 1. Do we actually need that? Do we have anything that made our model 1 special? Okay, yes. Oh, can I give a model that I've cloned a new name? Turkey model dot name turkey model. We'll find out together, won't we? Callbacks equals create model checkpoint, model name equals turkey model dot name. Damn it. TensorFlow, how to change model name attribute. Beautiful. How do we do this? When the brain goes numb and you call it mental freeze. So if we now load in our best model, And would you look at that? With just one value, our error metrics go through the roof. That's crazy. So let me just show you what this looks like. Time steps equals, let's just get, should we get X test here? No. What plot do we want? Oh, there we go. Okay. We need to reverse these. Did you catch that? My indexing was off. Good God, man, it was right. My indexing was off twice. Boom. Now let's get our predictions there. I don't actually want the train data. Or do I? Okay, we've got, once again, we've got an indexing size error. Sheik asks, during the journey of self-learning, is it common that one feels burnout or feels like not studying at all? If so, how do you deal with that? I take a break, or I realize one of two things. Usually when I don't feel like studying, I'm on the verge of increasing my knowledge in a certain field, and thus it becomes hard, and so I avoid the difficulty. Or, second thing is that what I'm doing is not fun. So if it's not fun, I'm not going to do it. So those are the two things. I'm either on the verge of something, of improving a skill level, or I'm not enjoying what I'm doing enough. And so I would consult myself to ask, is this just difficult to and not motivating for me to do because it's hard and I'm not quite sure what it is, or is there some way I could make this more fun? And usually you only find out that by taking a break, chilling out, go for a walk, play. What have we got missing here again? Ladies and gentlemen, come on. I've got an indexing issue everywhere because my data is all over the place. Oh. That's what we need. We need the negative at the end. Boom. We got it. We got it, friends. Right towards the end, when we're up against the wall, indexing issue was giving us grief. See? Look at this. Turkey Preds. Our model doesn't capture that last step. Let's make a little offset here. 300. Oh, What a drastic prediction we've got here. Our model failed to pick up that really important point. Out of this whole graph, the turkey graph, let's see. Out of the whole graph of the turkey problem, what's the most important point out of this entire graph? This one. And our model failed to predict it. Shock. Okay. So that's largely why forecasting is BS, because when you train a model on time series data, it's only going to capture the relationships between data that is within the sample. However, when you plot in a value that is so far ridiculously out of the sample, the model is not going to be able to capture those relationships. And would this happen on a typical day? Maybe. Probably not. But that is the most important kind of event, is the events that probably wouldn't happen. And I'm looking at this webcam as if I'm looking at the stream. But this camera's over here. I need to fix this setup so that the camera is in a place. Maybe I'll put it up here. That way I could like look into it and stare into the camera. So now we need to go back and clean up this notebook, of course. But first we're going to make a little update to the GitHub. Does anyone have any questions? Add turkey problem issue. Model can't predict on sample points massively out of distribution. Boom. So the code's been updated. Invite a successor. Let's get out of that. Oh, the TensorFlow deep learning repo is now at 1,000 stars. So thank you everyone who has starred this. But we have a pretty good notebook. I think we are, aside from cleaning up some things, maybe we need to get rid of this verbosity so that the notebook doesn't have model outputs, so that it's not extremely long. Yeah, okay. So we have some issues here with the model outputting way too many things. Let's fix this, hey? Or could we compare our different models? Let's compare the models, hey? Compare models. Yo, Cass, what's good? Yes, unstable deuce. You're completely right. Last week's massive drop in BTC price was driven by the CCP's legislative action. I know no way to have the model predict or properly handle that. Yes. 10 points to you. I'm going to put this in here. This is a great quote. Model can't predict things which are out of sample. Bold. This is a key point. How do I get my... I want to get the key emoji, but I can't in there. See? How could we have done that? all we would have gotten is, if we looked at the data, we would have gotten a drop like, okay, the drop, this is over exaggerated for a reason, just to highlight a point, to really drive home a point. I'm going to add some more text to this later, but let's compare our models. Cass, I'm really glad that you listened to that podcast with George Hotz. I really like George Hotz, actually. He's definitely one of my inspirations. I like what he's doing with Comma AI. I like what he does with his live streams. I like his thoughts. It's definitely guided me in terms of some things I do. Sarav, what did I miss? Well, Sarav, we just talked about the turkey problem and how in time series forecasting, our model is going to fail when we get points like this, because it's going to be trained on data that looks like this. But when we have a really significant data point like this one, which is however many standard deviations out of sample, out of the original training data, if we try to get a model to predict that point, it's not going to be able to predict that point because no other point in history was like that. So this is where the turkey problem comes into play. And it's really, really important for time series, especially in an open market, open system. It's what I want to get across in this notebook. Although I'm teaching students the skills of how to format and create models for a time series problem, when you're working on models in an open system, such as the stock market or weather is a great example. We've all experienced a weather forecaster making a prediction and then within a few hours it being completely wrong. In a closed system, things get a little bit different, but the modality of creating data sets and building models is going to be quite similar. However, it's very important to realize why forecasting is BS and why the majority of models for open systems are scams. So if someone ever comes to you and says, hey, I've got a great way to predict the stock market or a great way to predict the crypto market, whatever market, if they have the word market in there, ask yourself, is this a scam or not? Most likely, yes. Watch this for, I'm going to keep linking this video, turkey problem. Unstable Juice says, would using BTC price as a variable be beneficial to predicting altcoins? So the way I understand the crypto market in a very primitive sense is that basically all other cryptos aside from Bitcoin are linked to the price of Bitcoin. What that means is because Bitcoin is the most famous one, if its price goes down, chances are every other crypto is going to go down. Of course, there are exceptions to the rule. Same with the inverse of what it goes up. However, they are still part of an open system. So although their price trend is correlated with Bitcoin, if we can't predict the price of Bitcoin with any reasonable good model, so we've used a state-of-the-art deep learning model here, and we've just scraped to beat the naive model, which means predicting yesterday's price as tomorrow's price. So if we can't even do that for Bitcoin, yes, we could use the price of Bitcoin as a variable in an altcoin prediction. However, it's still based on the price that we can't predict. So it's still based on the price of Bitcoin, which, as we've shown, we do very poorly. But let's compare our models just to really rub salt in the wounds. Model results, we'll create a data frame. Because I believe, if I've done this right, let me know if that made sense. We want, all of our models have similar outputs. So let's do that. PD data frame, boom. And we want model 1. Or can I just do model 1.name? That's probably better. Nah. No, I'll just do model 1. We'll just do string names to keep it simple for now. Model 1, dense. Model 1, results. Model 2, dense. Model 2, results. Oh, there's also a great tweet here. I'm going to recommend Mark's Twitter to everyone. Mark's a really great just creator in general. Look at this. Time series forecasting, predicting stock prices using an LSTM. I reinvented this graphic with this entire notebook. So same vibe. Time series forecasting, predicting stock model prices using an LSTM model. Just because a model works for a set of data doesn't mean you should use it. So basically like palm reading, whatever this is. And then I commented here, and if it's a constrained physical system like predicting where a ball will land given some measured assumptions like gravity, force of ball, etc. The issue is with general time series forecasting, it's too complex a system to make any inferences on short-term movements. So look at this tweet. Highly recommend Mark's stuff too. Yeah, I'm going to link a whole bunch of great resources that I'd recommend for extra curriculum for this section. Basically, what this section is, the time series forecasting, is more so getting the data ready for a model, right? But just because you can get data ready for a model doesn't mean you should use the model. So that's what I'm pointing out here. Compare model. There's another great blog post. Nassim Taleb versus Nate Silver. And this goes off what Sarav was saying. Hey, Sarav, can you link that podcast? I'd like to listen to that, please. Talked about this on the Gradient Descent podcast. He was talking with respect to election forecasting and prediction markets. So, Red Hunter, welcome back. And that's a terrible color. I can't see that. Ashcroc, morning, my friend. How are you? So this is another great article. Great article on the troubles of predicting. Yeah, I'd highly recommend. This is by Taleb as well. And the reason, why should we listen to Nassim Taleb, right? Skin in the game. Of course, you don't have to agree with everything, but the beautiful thing is that he backs these things up with math. But we've just done this empirically, and he would probably actually encourage us to figure this out empirically. Even though we knew from the start that it wasn't going to work. However, I would highly recommend checking out all of his stuff, especially the Black Swan. That is what we're talking about here. This is a Black Swan event, an event that you can't predict. So model 3 dense. Let's keep comparing our models. I want to show you how much one thing changed. One variable changed our entire system. What did we even build? Conv1D, they're all bogus anyway. That's the spoiler alert for this module. The models don't work, but the data pre-processing does, which is often the most important point. LSTM, let's save this to Conv1D. Model 5 results. Friends, this is very exciting actually. I'm happy to finish the code off for this notebook. If I went too far, oh, this is another, I forgot this extra curriculum. Nate Silver versus Nassim Taleb. Great insights on predicting in an open system. And And then let's have a look at, I'm going to recommend the Black Swan book as part of this time series forecast. Black Swan, wow, look at the stuff I get. Black Swan book. I'm just going to put Amazon. That'll do. Extracurriculum, read Black Swan. Double Peno, what's good, my friend? Cas9, are you talking about... after I finish this code, is that what you're talking about? What's my next project? We can't include Model 6 because that's multivariate. Yeah, we can't. We'll put it in there anyway. That's fine, actually. Multivariate. After this, Cass, I'm actually very excited. I have a project lined up, but I've been thinking about for a while. However, I'm not talking about it just yet because I don't want to get the sense of accomplishment. However, I'll give you this. It is computer vision based and it is full stack. Those are the two things. And I will be building a lot of it in public. So, yeah, you might be interested. I'm going to be streaming it a lot and I'm going to be self-funding it and it's going to be really fun. And I'm probably going to work on it for at least a year. It's got a lot of long tail stuff that I'd like to work on in computer vision. Model 7, what did we build for this? This is just another dense with, well, we're not going to include that, are we? But it's a full stack problem. I've done enough teaching. So here's my thing, right? I've been a teacher for like the last year and a bit. And I've done enough teaching now. It's time for me to go back and get some skin in the game, a la Nassim Taleb, and build my own project rather than just sort of teaching things. I need to build something. I need to have something out in the wild that works, a service, a machine learning powered service. Where the hell is the NBeats model? See, this notebook needs a very overhaul. Oh, the stack model. Stack model results. Look, we replicated the NBeats algorithm. I actually think this might be a little bit of a scam too, this paper that they pushed out. I mean, Element AI lost a lot of cash. Element AI lose money. Hands out pink slip hours. What is pink slip hours? Oh, it's a pay to win. Pink slip hours. What's pink slips? I know that in Fast and the Furious. So they sold and then they fired all their staff. Okay. Well, no. I'm in the wrong frame of mind here. Credit has to be given where credit was due. You start a company, you fail, you should be held in the same respect as, or maybe not the same respect, but a similar level of respect as a soldier. Now, where's our stack model? Okay, we've got to compare the stack model. Model 7 is Model 8, which was NBeats. You try something and you fail. Your failure contributes to improving the system as a whole. So another great book by Nassim Taleb is Anti-Fragile. Individuals, fragile. system as a whole, anti-fragile. So if individuals are fragile, so someone starts a company and their company fails, or they start a startup and it fails, they might experience the failure. However, the rest of the system benefits from learning from their failure. The system gets better. What else do we do? Ensemble. Model 9. We need to fix this, but we'll just plot them together. It should look alright. To do, fix the names of the models / results. Are they comparable? Yeah, it's going to be a good... it is very exciting. I am excited for the next project. It's going to be exploring into things I've been wanting to explore in for a while, but I need to finish the course first, so that's out there in the world. And that is... that's going to be one of the driving forces for... Like, the revenue from the courses is going to pay for the next project, is going to pay for creating videos and creating the thing itself. Ensemble, let's get the ensemble results in here, and then finally we'll do the turkey. We built a lot of models in this. Model 10, turkey, turkey results. All right, let's see what this looks like. And now plot. What are we going to get? Some strange bar graph? Oh yes, good lord. Okay, we need, no, line graph. We need the kind equals bar. Oh wow, okay, so we see here that this is a great demonstration of how poor our turkey model is. Reminder, the turkey model, does this have a fig size parameter? Beautiful. So look at this. Our turkey model is absolutely blown out of the water compared to everyone else. On mean squared error, of course. That's always going to be higher. I think we plot everything... What if we plotted everything except mean square error? Because that's just outlandish, isn't it? No. I'm going to get rid of this. And then let's go model results dot head. And we are going to plot... no, I want to transpose this. I think that'll look better. Okay, there we go. Hey. Where'd my other... Oh. Yeah, see, look at that. The turkey is just absolutely off the charts. And we changed one value in that model. Let's now model results. We will get MAE, MSE. We'll just do MAE. Look at that. Woohoo! So the turkey just through the sky in terms of how poor it is. Remember, these are all trained on the same data. The only thing we did for the turkey model is change one value. Turkey problem. Great demonstration of the turkey problem. I wonder if we can scale these by log. Dot log. Pandas run log on a column. Data. Okay, we can do that. See, that emphasizes it more. It looks better. So our ensemble gets the best value. Okay, this is comparing. Sort model results by MAE and plot them. So the ensemble gets the best results, which makes sense. Okay. I think we should start cleaning up the code here. Oh, that could be an exercise. Exercise equals get the latest up-to-date data on Bitcoin. Train a model and see how it goes. There needs to be a note here for where we make forecasts. Note, forecasting models need to be retrained every time a forecast is made. Why? Because if Bitcoin prices are updated daily and you predict the price for tomorrow, your model is only really valid for one day. When a new price comes out, it will have to retrain your model to incorporate that new price to predict, e.g., the next day. Incorporate that new price to predict the next forecast. Why can't I get my emojis in here? Key emoji. Yo, Techie Chan, what's good? Okay, we need some cleaning up of this. Where are all my up to here's? I wonder what would happen if we did that. Let's restart the runtime and start stepping through it. Okay, so we have time steps as a value. Way back when we first started this notebook, we saw that if you create a train and test set like this with your forecasting data, you're going to be using values from the past to try and, values from the future to try and predict, or your test set is going to be scattered throughout the past, but you want your test set to be in the future, because that's what we're trying to do with time series forecasting, right? Let's increase these legends. They can be bigger. Yeah, so this is what we want to predict. We want to use the values in the past to predict the future. Plotting function. Yes. Okay, so we're going to build modeling experiments. So this will be model 0. Deep models, which are fully connected. This will be an exercise, actually. Oh, this is very, very exciting. We can clean up a whole bunch of this code. The notebook will start to make sense. I think it already does start to make sense. It kind of, if you just went through it sequentially, it doesn't have any text-based annotations, but you would get a fairly idea of what we're doing here. done. Very important point. Deep learning models, you can almost build any kind of model for your specific problem, as long as the data inputs and outputs are formatted correctly. However, just because we can build almost any kind of model, doesn't mean it'll perform well / should be used in a production setting. Very important. Model 8 is going to be... Wow, why is model 8? Oh no, model 6. We're going to go here. Model 6 is... dense model with multivariate time series. Adding in the Bitcoin block reward as a feature, and then model 7 equals dense model using TensorFlow, TensorFlow TF data API for inputs, and then model 8. Wow, we built a lot of models in this. This may change as well. This is not the full course material, but it's close. I think the outline is here. By the end of the week, I'm going to have all of this typed out, you know? So that's what we're doing. We're now going back. The code is all there. The code that I want to include in the final notebook is here. All the rough code. We may take some out that's not needed. We may add some that is needed, etc., etc. But we are now going back through the stages of formatting or writing text around the code to explain what's going on. NBEATS algorithm, and then model 9. Ensemble. Yeah, 10 models will be enough. 10 models is a cap. Well, it's 0 index, so it's going to be 11, isn't it? Model 9 can be ensemble. Multiple different models, optimized on multiple models optimized on different, we only say different twice, on different loss functions. And then model 10 is going to be turkey model. Same as model 1, but with a turkey problem introduced into the data. Oh, this is beautiful. Okay, so if we make the naive forecast, does this work? Ludo Car, what's going on? Good morning, or it actually, no, sorry, it's good afternoon here. Good afternoon from Brisbane, Australia. What is the time? 3:58. First they ignore you, then they laugh at you, then they fight you, then you win. Well, it depends. What if they're a good fighter? Zoom in on the naive forecast. Evaluating. Yep, I'll get rid of that. Yeah, so this is a really good book on time series forecasting. It is for R, the programming language R, not Python, but I mean it's math, so we can just re-implement it in Python, which is what I've done. So if we got the MASE, which is mean absolute scaled error, which is an alternative to using percentage errors, was comparing forecast accuracy across series with different units. So if your series have different units, we can use MASE. And I believe with the MASE, one of the models, the naive model, yeah. So the MASE, the naive model, should, based on the formula, should predict 1, far out, I've got a lot of crappy tabs open, should predict 1 for the naive forecast because of how it's formulated. So for a non-seasonal time series, which is what we're using, non-seasonal, price of Bitcoin, non-seasonal, a useful way to define scaled error is this. So that's a good website. Now, if we go here, what did I just want to look up? Oh yeah, seasonal time series data. We can see this pretty clearly. You've all seen this. Milk production, there we go. So it follows a seasonal pattern. Maybe it increases in the summer months and decreases in the winter months. But the overall trend here is increasing over time, but it still follows that pattern, right? It's got this pattern here is replicating over time. That's a seasonal time series. Over the long term, it's going up like that. So that's the trend. Seasonality is these little peaks here. Trend is from here to here. Oh, this is a good one. Oh, time series patterns. This is great. Trend, seasonal, cyclic. Wow, I'm going to read this tomorrow. Let me save that. ML time series. I love it when you stumble upon things that you should have read earlier. So maybe this is up here. What is a time series? There's lots of different types of time series. What kind of time series data are there? Of course, we can't cover them all. Otherwise, that'd be a whole course in itself. We just want to introduce students to time series problems, or forecasting. In this case, predicting the price of Bitcoin because we all want to get rich. So I implemented the MASE error in TensorFlow. It's not that hard. It's in SK time, which is scikit-learn but for time. If we go back, it's just this formula here. Let's compare. So we have, this is the MAE, the top on the, that's the E. So the training MAE up there. So this is non-seasonal time series. Oh, what did I do? Show pop out. Ashcroft says, maybe include profit in your experiments. Profit can be an extension because this is TensorFlow based, so I wanted to keep it here. But what Ashcroft is talking about is Facebook profit. Maybe this can be an extension. Other modeling or time series modeling resources. Facebook profit. Thank you for that though. I believe it's actually pretty easy to use too. You just use, you give it a, yeah. Yeah, if someone wants to use profit, they can try profit. We'll just focus on TensorFlow. Who knows, profit may beat all of our models, but maybe I could see that as an exercise. Exercise, no, we'll come back to that. If you can use TensorFlow, you can use profit. And where are we up to here? Evaluating a time series. So we implement MASE, then we create a function, evaluate preds, and we get a whole bunch of metrics here. We just do every metric here. MAE, RMSE, my dyslexia is kicking in here, something fierce. MAPE, SMAPE, recommended not to use, though it is used in forecasting competitions. Hence why we don't have it here. And we have MSE because why not? It's in Keras. Now, what will MSE do? MSE will emphasize outliers. So remember, we actually covered this in a previous module. So let's just put here, MSE. No, we can't put that there. Puts an emphasis. Is that how you spell emphasis? Yep. On outliers. All errors get squared. And then we run that function and then we get the naive results. Yes, that makes sense. Oh, mention other kinds of models which can be used for baselines. Okay. So TensorFlow decision forest, moving average, Facebook profit. TensorFlow decision forest. New addition to TensorFlow. TensorFlow now has random forests and gradient boosted machines. Moving average, etc. We're going to be focused on pure TensorFlow models. Maybe a REMA. Now, what section are we up to here? Format data. I'm going to make this format data part 1. Creating train and test sets for time series data. This can be format data part 2, windowing dataset. Why do we want to window? Well, I'm going to move this up here, aren't I? So yeah, if we window for 1 week, we use the previous 7 values to predict the next value. That's why we window. So the default horizon and default window can be 7, even though we set horizon and window size. Create a labeled function. Yes, this works. Ludocar says, how long do you invest time on reading articles? Well, it depends on what articles. So usually I don't have a set amount of time of what I'd read articles. If something interests me, I'll read it. But I like to do like an hour or 2 of reading per day, and then 3 to 4 hours of actual like trying things out. And then that's almost about it. Any books you recommend on health and fitness? Oh. Let me think. You know what? I almost don't recommend any books on health and fitness. Because a lot of it is trial and error, right? Finding out. See, the beautiful thing with code and programming is that there's generally, I mean, you can do what we're doing many different ways, but when it comes to getting the best results, that's a measurable thing. But with health, it depends on what you want to do. So for example, lately I've been listening to a lot of stuff on jiu-jitsu because I'm trying to improve in jiu-jitsu. But does that necessarily help someone who wants to just improve their general health? For general health, I would now recommend reading Lindy material. So, Lindy newsletter. Subscribe to this newsletter. What is Lindy? Things that have been around for a long time will probably stay around for a long time. So, let's go into this and find out on diet. Here we go. On diet. There's part 2. Part 1's there. You can find that. On sleep, sleep is really good. You can find part 2 or part 1, whatever. All the different parts. You're smart enough to do that. I'd really recommend this. A lot of mental health stuff here as well. I'd argue you want to... Oh, here we go. Here's for working out. Stress the heart and bones. Yeah. Highly recommend. Deep nutrition. I only listened to a start of that. I found it pretty bland, but it does make sense. However, it is also hard to imagine. So one of the arguments is basically if you do damage to your nutrition, it's going to be passed on to generations in the future. That was essentially the whole message. And I think there's too much fluff around that. I think Lindy will help you out with that as well. That's basically Lindy's message as well. Okay, now we need to save our model's best performance. We can get rid of this. Any YouTube channels for health and fitness? Not really, to be honest. Whatever comes up. I like listening to podcasts. That way you get a good, diverse influence of different people talking about health. Probably for general, like seriously though, for general health, Lindy is probably the best filter to use. Just use the time filter. If something hasn't been around for a very long time, then avoid it. Again, but there is also going to be exceptions to the rule. This is the argument for fake meat, right? Let's have a look at this. Impossible Foods, patents. Right? So this is a fake meat burger. However, it's basically a product. Well, it is a product. I mean, you could argue regular meat is a product, but why does food have patents? Why does such a general necessity for human life, why do you need patents for that? So the amount of engineering that has gone in to create this fake meat burger, I'd like to know a world that put that same amount of engineering into regenerative farming practices. So one could argue, yes, being vegan. So that for me, the biggest argument for veganism is to reduce factory farming, and I would agree with that. However, animal products have been part of a human diet since inception of humans. So and you just have to look at nature. Nature basically designed itself to eat itself. So if you look at every single animal, it eats it in some way. There's a circular pattern. So this in terms of the Lindy filter would not be Lindy, right? Food never had patents, and so that's my take on, well, overall take. I mean, we could go deeper if you want, but I need to focus on this code. My take is: can you go up to a farm, an organic farm, and buy the food from that was raised or grown on that farm? If you cannot buy the food from there, you should generally avoid it. That doesn't mean never have it, and sure, have some fun, like eat a cheeseburger once in a while. But that is my general synopsis on nutrition. Is could you go to a nice organic farm and buy whatever you're going to eat? If you can't, well then you should probably avoid that. Otherwise, there's too many rules that people make, like no carbs before 8 and all that sort of stuff. Just experiment. Treat yourself as an experiment. Anything that I say is probably going to change depending on what your lifestyle is. Okay, so there we go. This is looking good. Health returns the best results over time. So you want to develop habits that are going to help you over time, which is why my mottos for, like if you go to my website, Eat, Move, Learn, Make, what's my motto for learning? Keep learning. What's my motto for moving? Keep moving. What's my motto for creating? Keep creating. And then eat is, of course, you have to keep eating, but if you wanted to put something there, it would be eat what you could grow or raise. So we trained model 1 for 100 epochs. Should we do that the same for here? Batch size. I don't like all of these printouts, but that's okay. Might as well train all of these for 100. Well, does that take too long? Cass says you drink Soylent for about half my calories. What is Soylent? Oh my. Where's the ingredients? Here we go. Ingredients. Filtered water, soy protein, isolate, maltodextrin, high oleic, oh Jesus. Sunflower oil, canola oil, natural flavors, vitamin and mineral premix, soluble corn fiber, soy lectin. Okay. This for me does not pass the time filter. Right? Especially the high amounts of seed oils. High oleic, sunflower oil, allulose, canola oil. So what are these high in? We're getting distracted here. But sunflower oil components. Is this omega-6? Sunflower oil, omega-6. There. Sunflower seed oil is very high in omega-6 fatty acids. So, one of the... Now, I'm not up to date on the research here, but one of the problems in nutrition is if you have an imbalance between omega-6 and omega-3. Sunflower oil in products, especially in a lot of many modern products, this is what you'll notice. Start to look at food labels. See how many of them have high oleic sunflower oil or just sunflower oil in general, and canola oil. So when your balance of omega-6 is out of whack with omega-3, not ideal things happen. So I'll let you do your research into that because this is a coding stream. But also, for any type of ingredient list, ask yourself, does this pass the Lindy filter? Now, it's your personal choice on whatever you consume, but for me personally, I use the Lindy filter, which you can see, Lindy newsletter diet. So just search this. Time filter. Jose asks, do I share this on YouTube? Yes. On my archive channel. Did we train this model? Yeah, fruit oils. Ludo, you're right. Olive oil is one of the best. Fruit oils are generally better than seed oils and vegetable oils. So olive is a fruit. Avocado is a fruit. Avocado oil is good. Coconut oil. Time filter. That's what you want to use. Olive oil's been around for millennia. Okay, this outputs a lot too. Don't really want that out. Maybe we can do it like this. No, that's going to be a dictionary, isn't it? Maybe we can zip. Keys. That's not going to work, is it? That's all right. Thank you for sharing that channel, Ashik. Cass says the ratio of omega-6 to omega-3 fatty acids in soy at 4:1, therefore delivers a better balanced ratio of PUFAs to your diet. Okay, it might be balanced. It's made by food scientists, actually. Here's my gripe with food scientists, though, is that all foods are made by food scientists that aren't grown on a farm by nature. And so for me, I prefer nature to be my food scientist rather than some guy in a lab. Or some girl. Someone. That was actually my undergraduate degree, was nutrition and food science. So before machine learning, I was a nutrition and food scientist. And the made by scientist argument is also dangerous because the nuclear bomb was made by scientists. Beautiful. So in terms of food science, I know all the tricks that people use and food scientists use to make... Think about these companies though, right? I mean, of course, a farm is for profit, but if we look at like modern day food companies, what are they doing? They're trying to make profit. Yes, of course. There's a lot of tricks that you can do to use less expensive ingredients to make food on a large scale. Okay, so now we're up to Model 4, making a Conv1D. We're just stepping through the code here just to make that it's not like an outlandish amount of crap here. We have to use a Lambda layer here. I don't think we've covered that in the course up to this part. I wonder if we train this model for 100 epochs, what do we get? Verbose equals 0. And we'll set the batch size to... Oh, what did we set the batch size to? Oh, we've just been leaving it as the default every time. What did we train Model 1 with? Let's go back and have a look. What are the default parameters for this notebook? That's actually... Look, Cass, after saying all this, like, I'm not telling you what you should and shouldn't eat. That's actually one of the reasons why I got out of nutrition and food science. I really just wanted to learn the mental model of how I should approach these things, rather than looking for some gospel of telling me how I should and shouldn't eat. Reason why I got into coding was because you tell a computer what to do, and it does it. Whereas the field of health is so varied between individuals, it's a lot harder to do anything at scale, which is kind of what my brain works better for. Things that repeatable actions. So the main reason I studied nutrition and food science was for my own sake, rather than to be able to... I believe for health, that should be in the case of everyone's own hands. Everyone... As much as I enjoy machine learning, health is my #1 priority. Every individual should be in charge of their own health. and then their education. Okay, so let's set up some default parameters. We haven't really been doing that. Batch size 128. Okay, let's just do 128. I might write a note about that. Batch size equals 128. Epochs equals 100. Default parameters. So if we train for 100 epochs, how does our convolutional model go? My guess is not that much better than it originally went, because all of these models actually perform quite poorly. I get these goosebumps every time. I need them. Go back to the side. Oh, the Conv1D model isn't performing at the best so far. Potentially, yes, but does it... Is it much better than Model 1? Yes, slightly better. Is it much better than the naive model? Again, slightly better, except on MSE, RMSE. This? Is it what you're talking about, Sarav? This is bare. Nice and simple. Just a text editor. Now we're going to do an LSTM. Let's see what happens here. So this is where we start adding a multivariate, another feature column, the block reward size, the amount of Bitcoin received by a block. This halves every 4 years. So when you mine a block of Bitcoin, you get a certain number of Bitcoin. When it first came out, you got 50 Bitcoins. That's a pretty good deal. Then you got 25 on the 28th of November 2012. Then you got 12.5 on 9th of January 2016. And then you got 6.5 on the 11th of May 2020. So I wonder if this information, what we're trying to do here is if the block size is reducing over time, does this influence the price? So we can quite easily append it just like that. We do some date time differencing here in the form of date times. We just convert these dates, 28th of November 2012 to a date time. Boom, and then 9th of July 2016 to a date time, date time. Wonderful. Now we've got... So the trend here is that block reward reduces, Bitcoin price goes up. Does this improve our model? And here we create a windowed data set with pandas. So we can use the shift function in pandas if we wanted to. So then we've got the price and the block reward, and now we're going to shift the price 7 steps. So now we're using window size plus window size and block reward to predict the horizon, which is, the horizon is what we're trying to forecast into the future. Then we get rid of the... So this is our X data now. We've got an extra feature here. That could be an extension, actually, scaling this to the same values or the same scale, because block reward is going to be on a different scale to the price. That might influence the model, but generally deep learning models are quite good at finding patterns in this kind of data. We could have actually been doing that from the start, and that's scaling the data. Yeah, that can be an exercise. Help for univariate / multidata. Does this affect model training or evaluation results? Then we split it into train and test sets, nice and simple. Batch size we can increase. Wonder how our conv1d model goes on this. Let's make a copy of this and test a conv1d model on this. We'll keep pushing forward over here. Damn it. We'll try that experiment later. Now we can make TensorFlow windows. Do we need this? You know what? I think we're going to can this. They may come back to bite us, but I don't think it will. So now our ensemble is model 8. I think that's enough. That'll be 10 models in total because we're 0 indexing. One, two, three, 4, 5, 6, 7, 8, 9, 10. Beautiful. Yeah, I think that'll be good enough, actually. Less but better. So did we make the future forecast? Yes, we did. Do we make a forecast of 1? Yes. Plot uncertainty of future forecast. Show how the forecasts break down very easily? Yes. This is next. And we've done turkey problem. We've compared all the models. Build more modeling experiments. Multivariate time series we've done. Need to bring this up here. Done, done, done. That can be an extension. See how a model performs on future time series data. Cleanup code up to the n beats algorithm. All is runnable. Have to tidy from there onwards. That's a beautiful plot there. To do, we also want to clean up ensemble code. Can this be functionized? E.g., saving the models instead of having them predict whilst they're inside a loop. Data inputs to ensemble should be a TF data set. Up to here. Clean up code from here onwards. Make sure it runs, evaluates correctly. Set all models to have keep outputs to a minimum. And then we also want make ensemble model. Okay. So we made a bit of headway here today. We introduced the turkey problem. We built a turkey model, and then we compared all of our models. So over the next few days, we're going to keep tidying this notebook up. By the way, happy 1st of June. It is the first day of winter in Australia. Then we'll set some exercises and just keep going from there. So yeah, that's the next couple of days worth of streams, is cleaning up this notebook ready for publication. I mean, it already is published. You can get it on the GitHub. But just we're going to start adding annotations to explain the stuff that we're doing here. So let's get rid of this, because this will be a bit easier to load after this. We'll save it. Okay, yeah, so we've got more than enough code here for a module. I'm going to save this in GitHub. Add turkey problem code and add model comparison, clean up outputs. So if you want the code, it is available on GitHub. Linking that in the chat now. Otherwise, you can see it at mrdeburk/TensorFlow Deep Learning. Thank you so much for joining into the stream. I will probably see you tomorrow. But yeah, wherever you are in the world, keep learning, keep moving, keep creating. See you next time.